Why do we make alloys? Alloys are made and widely used in the industry because alloys are stronger than the original pure metals. For example, steel is composed of 99% iron and 1% of carbon. Stainless steel is composed of 74% iron, 18% of chromium, and 8% of nickel. Bronze is composed of 88% copper and 12% of tin. Brass is composed of 75% copper and 25% of zinc. Duralumin is composed of 95% aluminum, 3% of copper, 1% of magnesium, and 1% of manganese. Magnesium is composed of 70% aluminum and 30% of magnesium. Pewter is composed of 96% tin, 3% of copper, and 1% of antimony. Solder is composed of 50% tin and 50% of lead. So, is alloy harder than its pure metal? Set up the apparatus as shown and attach a steel ball to the surface of a copper block using a cellophane tape. A 1 kilogram weight is released from a height of 50 centimeters above the surface of the copper block onto the steel ball. Then, detach the steel ball from the copper block. Using a vernier calipers, measure the diameter of the dent form. Now, replace the copper block with a bronze block and attach a steel ball to the surface of the bronze block using a cellophane tape. A 1 kilogram weight is released from a height of 50 centimeters above the surface of the bronze block onto the steel ball. Then, detach the steel ball from the bronze block. Using a vernier calipers, measure the diameter of the dent form again. After measuring both of them, we have observed that the diameter of the dent on the copper block is bigger than the diameter of the dent on the bronze block. Therefore, we can conclude that bronze is harder than copper because bronze is made up of a mixture of copper and tin, where the copper atoms in the bronze alloy cannot slide over one another easily as they are blocked by the tin atoms. So, bronze alloy is harder than pure metal copper. Alloying causes metals to become more resistant to corrosion, such as rusting. It changes the properties of metals to become stronger, harder, and tougher. It improves the appearance of metals so their surface is shinier and more sparkling. It changes the melting point of metals. It also changes the density of metals. Is it true that the rate of corrosion, such as rusting of iron, steel, and stainless steel, different? Set up the apparatus as shown. 100 cubic centimeters of water is heated to boil in a beaker using a Bunsen burner. When the water starts to boil, turn off the Bunsen burner. Add 2 grams of agar into the beaker so it dissolves to form an agar solution. Then, 10 drops of potassium hexacyanophosphates solution are added to the agar solution. After a few minutes, pour the mixture into 3 different test tubes. An iron nail, a steel nail, and a stainless steel nail are rubbed with sandpaper to remove any rust on them before they are placed into the test tubes. All the test tubes are left in a test tube rack for a day. It is observed that the intensity of the blue color of the agar in the test tube with an iron nail is very high because it has a lot of rust, whereas the intensity of the blue color of the agar in the test tube with a steel nail is low because it has little rust. However, the color of the agar in the test tube with a stainless steel nail remains unchanged because the stainless steel nail did not rust. In conclusion, the rate of rusting of iron is higher than steel and stainless steel, and the arrangement in ascending order of resistance to corrosion is iron, steel, and stainless steel.